Object-oriented programming concepts in C++. The topics of discussion are constructors, encapsulation and abstraction, polymorphism, and friend functions. What are constructors? Constructors are special class functions which perform initialization of the object. Constructor has the same name as the class name. A constructor is called automatically whenever an object of that class type is created. A constructor has no or many parameters, but a constructor does not return any value. Types of constructors. The three types of constructor are the default constructor, the parameterized constructor, and the copy constructor. The default constructor has no parameters. The parameterized constructor has one or more parameter. Copy constructor has a new object initialized as a copy of an existing object. Here is an example for default constructor, parameterized constructor, and copy constructor. In the example of the default constructor, the class throttle initializes the variable POS with a value of 0. Note that it does not have any parameter. The constructor is called when the object is created in the calling function. That is, when you write the C++ statement throttle T, the object T is created of type class throttle. At that statement execution, the constructor is called. C++ provides the default constructor. It is not necessary the user has to write the default constructor. Parameterized constructor. In the parameterized constructor, the constructor receives input arguments. In this example, in the declaration of the object T, it has an input parameter 5. This 5 is initialized as the value of the member variable POS by the constructor throttle. Copy constructor. Copy constructor receives the object as its parameter. Consider a object T1 declared with the parameter as another object T. This is an example of using a copy constructor where the object of a class is a parameter to the constructor of the same class for a different object. Encapsulation and abstraction in object-oriented programming. Encapsulation is defined as binding together of data and the function that manipulates them. C++ classes provides encapsulation using member variables and member function. Abstraction is defined as the concept by which only essential data and its processing are presented to the users. C++ classes provides abstraction using access modifiers. This is a sample C++ program that provides encapsulation and abstraction. The variable position and the function throttle and shutoff are put together in the class throttle. The scope of the variables and the functions are specified using the access modifiers private and public. Let us discuss in detail about various access modifiers in C++. Access modifier or specifier specify the access restriction to the class members, that is, the member variables and the member functions. If the access modifier of a member variable or member function is public, then the member variable or member function is accessible within the class as well as outside the class. That is, the member variables and the member function are accessible using the object of the class in which it is declared. If the member function or member variable is declared with the access modifier private, then the member variable or member function is accessible only within the class and also the friend functions of the class. If the member variable or member function has the access modifier protected, then the member variable or member function is accessible only within the class and the derived class of the class in which the protected variables and functions are defined. The default access modifier of a C++ class member is private. What is polymorphism in C++? Polymorphism is a phenomena in C++ object-oriented programming where functions and operator have a different meaning at different contexts. The two main types of polymorphism in C++ are function overloading and operator overloading. In function overloading, the same function name is used for many function definition but with different set of arguments or arguments with different data types. Each of the overloaded parameterized function have separate definition. For example, the function sum is overloaded. The first definition receives input variables as integers and adds them and returns an integer value. The second definition sum receives a single parameter which is of data type float. It adds the variable with itself and returns the float value. The third definition receives two float values, adds them and returns a float value. Here you can notice the data type and the number of values in the argument list and the return value differs. The constructor in C++ can be overloaded. That is, the parameterized constructor can initialize the object in different ways. Here is an example of function overloading in C++. The class addition has overloaded function sum. The first definition of sum receives integer variables and return the sum of the integer variable. The second definition of sum receives the float variable and returns the sum of the float variables. And these overloaded functions are accessed using the addition object obj from the main function. Which overloaded function is executed is determined during the runtime of the C++ program. If the arguments of the overloaded function is integer, then the first definition of sum is executed. If the arguments of the overloaded function is float, then the second definition of sum is executed. This is determined during the runtime of the C++ program. Operator overloading in C++ means making the compiler's built-in operator symbol work with programmer-defined meaning. That is, the operators have special meaning in a particular program. Operator overloading is achieved using classes and objects. The list of C++ operator that can be overloaded is given in the table, and also the list of C++ operator that cannot be overloaded. The dot operator, the scope resolution operator, the conditional operator, and the size of operator cannot be overloaded in C++. Operator overloading is achieved in C++ using operator functions. The operator functions are member functions or standalone function in a C++ program. The syntax for operator function declaration is return type followed by the keyword operator, the operator symbol, which can be plus or minus or any symbol of the operator that can be overloaded, followed by the parameter list to the function. Usually, the return type and the parameter of the operator function is the object of the class in which the function is declared. Consider, for example, the operator plus is overloaded in the class OF. The return type of the operator function plus is OF, and the argument it receives is a reference parameter of type OF. The operator equals and ampersand are overloaded in C++. The equal to overloaded in C++ copy each data member of the object to the object of the same class. The ampersand overloaded in C++ returns the memory address of the object. The example given here illustrates the overloaded equals and the ampersand. The main function creates objects C1, C2 and PTR of the class OO. While creating the C2 object, the X and the Y value are initialized as 5 and 6 respectively. The assignment statement C1 equals C2 assigns the value of C2x, that is 5, to C1x as 5, and the value of C2y, which is 6, is assigned to the value of C1y. When the object is a pointer, we use the assignment statement as ptr equals ampersand C2, where the memory address is assigned to the object. Why do we overload an operator in C++? Overloaded operators have appropriate meaning to user-defined types, so they can be used for object types. An operator must be overloaded to be used on class objects in C++. Operator plus can be used for adding two objects of user-defined class. Let us see examples of operator overloading. Here is an example of binary operator overloading in C++. The example consists of the class OP class, which defines the overloaded plus operator function operator plus, which has the argument of object OP class and returns the object of type OP class. In the main function, we create two objects C1 and C2 of type OP class. The purpose of the overloaded plus function is to add the object C1 and C2. The C1 object has the variable x initialized as 2 and y initialized as 3. The C2 object has the variable x initialized as 3 and y initialized as 4. The purpose of the overloaded function is to add the value of x of the C1 object with the C2 object and the value of y of the C1 object with the value of y of the C2 object. Hence, we specify the operator overloaded function, and in its definition we specify as x plus c dot x, where c is the argument to the operator plus function, and y plus c dot y, and return the object TMP of type op class. From the main, we call this operator plus function not as a regular function call, but with the operator. When you specify C1 plus C2, automatically the compiler recognizes it as the operator plus overloaded function and calls the function operator plus in op class with the argument C2, and the operator plus class belongs to the object C1. It is similar to C1 dot operator plus argument C2. The output of the operator plus function is stored in the object C2, which can be printed using the function print of the class OP class. Here is an example of overloading the plus plus unary operator. The unary operator plus plus is overloaded to increment the value of x by 1 as well as the value of y by 1, where x and y are member variables of the OP class. In the main function, we create two objects B and C of OP class. The x and y value of object B are assigned a value of 1. The assignment statement C equals plus plus B calls the operator overloaded function operator plus plus. Note that when a unary operator is overloaded, it does not receive any argument. It only has the return type. We increment the value of x and y in the overloaded function and return the object type TMP. Here in the main function, C, the object of class OP class, is assigned the incremented value of object B. The value of B and C is displayed in the standard output device using the member function print of the OP class. Friend functions. The friend function is not a member function of the C++ class, but it can access the private member variables and member functions of the C++ class to which it is a friend. The friend function declaration has a keyword friend, but the friend function definition does not associate the function with the class. That is, no scope resolution operator is used while defining the friend function. Consider the example given here. The class sample has a friend function print that prints the value of the private member variable count. The declaration of the friend function print has the keyword friend followed by the return type of the function, and the argument is the object of the class to which it is a friend. The definition of the friend function print does not have any scope resolution operator. It is simply defined as a C++ function return type followed by the function name print and the argument, which is the object of the class to which it is a friend. Using the object, the friend function print will be able to access the private member variable count. In the main function, we declare two objects S1 and S2 of type sample. To print the value of count in the object S1 and S2, we use the function print, which is a friend to the class sample. This presentation discusses the basic concept of OOP in C++. It discusses constructors, encapsulation and abstraction in C++, polymorphism in C++, which are the function overloading and the operator overloading, the friend functions in C++. I highly recommend that you execute the example given in this presentation. Thank you.